What's up, Mr. Oldman Stop Sign? Old GK here, waving at you. We got two twins right here. Here's the one you sent me. This right here is an old school one. That's an older one, which is up for repair. And yes, you are right. The inside of this is pretty clean. It is actually pretty clean inside of this. You know, it isn't like it was in a very dirty environment at all. So the insides do look pretty dang clean. Looks very good, actually, pretty clean. As you see with this one, it does not look all that clean. And this is an old one where the plastic right here is even breaking off. But we're not looking at that, we're looking at this one. Okay. Now, this one has definitely has had a catastrophic failure, is what I like to call it. If you take a look at the output combiner right here. Okay, I'm going to explain how this works to you real quick, just so you can understand what's going on, buddy. All this is 1, 2, 3, 4 2-pill amplifier modules, or boards. 1, 2, 3, 4 Texas Star 350s. 4 2-pill boards. Okay. We need to get an RF signal to all 4 of these boards at 50 ohms. So this is all about 50 ohms. If I just took a wire and came in here and just split the wire off to all 4, it would take 50. Come in. Sorry about that, but anyway, if I just came in here with a wire and just split the wire off into 4 wires, it would take 50 ohms and divide that by 4. And instead of giving each board a 50 ohm signal, it would be giving it a what is that, a 12 ohm something signal or whatever. So you can't do that. So what we have to do is we have to use splitters, which are these. And yes, these look identical to the ones on the back. They're just being used in a different way. These are being used to split. So here's how it works. Your signal comes in right here on this connector through this gray wire right here. Okay. If you don't key the amp and just key through it, it's going to come in right here. Then it's going to go to this. Zoom in a little bit. It's going to come in right here. If you do not have the amp turned on, then this leg right here is already touching this leg. Okay, so it's going to come into here to here, go down this wire that you see that's going diagonal. It's going to go through that wire going to here. Okay, and this leg is already touching this leg. So then since it's already touching that leg, it's going to go to here like this, back out the amplifier. Okay. Oh, did I do that backwards? Yes, I did do that backwards. I did that backwards. I saw this red wire down here. You know what, brother? I just now saw that. Either somebody has unsoldered this, or it popped off when it had the catastrophic failure. Or you never. Yeah, I'm sure that probably happened during the catastrophic failure. Everything got so hot that wire popped off. Yeah. Or it could be a small possibility that it popped off and caused the problem. Some of these things you just can't know 100%. But it's backwards. The input's right here. Sorry. That's the wire going over to the keying circuit. So it's going to come through here. So these two are touching. These two are touching. So it's just going to come just like that. Alright, but when the amp is on, and when you are keyed up, here's the way it's going to work. Your RS is going to come into here. Alright. This is your common On a relay, you have a common, a normally closed, and a normally open. This thing with a wire on, this is your two normally closed leads, and these two leads are touching these two leads. But when you key, now the normally closed is going to be unswitched from, and now this common lead is going to go and touch this lead. Okay, so now this lead's going to be touching that lead, and this lead is going to be touching this lead. This is a different kind of relay. It can be confusing. The way the armature works in this relay is completely different, honestly, than this relay. And that's why it's kind of weird the way it does it. So then the RF's going to come in. This is touching this lead. It's going to come here to this lead, and it's just going to flow through this yellow capacitor. This yellow capacitor right here is just a coupling capacitor. You don't even have to have it there, but that's what they use. So it's going to flow through this capacitor, okay? Let me zoom out now. Now it's going to flow down on this trace you see right here, the capacitors do, and then that trace ends right here at this splitter. And there's your input tuning capacitor right there. So it goes to this splitter. This is your number one main splitter. So it goes to this splitter, wraps around this toroid, which gives it inductance. And then the main splitter splits one signal off to two signals. Okay? So it's going to go to the main splitter, one signal, and then split off into two signals to these two. See, this is the main splitter. Then it splits that main signal into two. So one goes to here, then one goes to here. So these are your two, what I call sub splitters. All right, now at this point, it's split off there and split off there. Now it's time to take this and split it two more times again. So this first one took one signal, split it into two. One here, one here. Now this is going to split into two and go to this 2-pill section and go to this 2-pill section. This 2-pill section, this 2-pill section. And that's how the RF gets to each of the 2-pill sections. Now the same exact thing happens on the output. And the output combiners are real close to each other on the back. This output combiner is taking the signal from this 2-pill section and this one, and is combining it into one signal. This one's doing the same thing, taking the output signal from this 2-pill, the amplified signal, and this 2-pill, and combining it into one signal. So now we have one signal here and one signal here. Now it's time to combine both of these and turn that signal into a single 50 ohm signal. That's what your main combiner. These are sub combiners, main combiner. Here's your main combiner. So that one signal that just got combined, two signals just got combined into one, goes to here. This one goes to here. Now your main combiner, along with these three metal clads, which is three 225 picofarad metal clads in series, equaling a 1500 volt capacitor. Those three 225 caps in series equals one 1500 volt metal clad capacitor. I can't think right off the top of my head what that equals. I'd have to do the math to see. That is an odd number. But then it goes through right here, comes to this lead to there. Alright, now here's what's happened. There's been a catastrophic failure. Okay, as you all have already noticed and you've already pointed out to me, it's hard to get any light down in here. Let me just turn off my headlamp. That 10 ohm resistor. What is that 10 ohm resistor? What are all these 10 ohm resistors? This 10 ohm resistor is part of the biasing circuit. Okay? This is actually part of the biasing circuit. These two 10 ohm resistors is part of a voltage divider circuit, which is part of the biasing circuit. Okay? You got these two 10 ohms, and then you've got this resistor right here. You see it right here. And if you look at that resistor, it's blown. The resistor over here for this one is blown also. Usually those resistors do not blow. This is my experience. Usually those do not blow. Unless there has been a over voltage issue, meaning someone has ran the amplifier on too much voltage. Okay? That is not the only way that can happen. That is one of the main ways, because this right here, oh, my solder, I got my solder wrapped around this pin. I like to solder that way a lot. I wrap it around a pin. This is hooked up to the biasing circuit. Okay, it's in conjunction with this. So this is a resistor. Okay, the 12 volts flow through this resistor in series. All right, then this resistor, which is a 1.8 ohm resistor, solders to the end of this leg of this resistor to ground. That is called a potential divider, a voltage divider circuit. All right, and not only this resistor, but these also. And all three of these resistors are in parallel to ground with each other. Okay? That is why you see that these have popped. A lot of times, if these 10 ohm resistors had popped due to RF blowing the transistor, a lot of times you will just see these resistors blown and not this one. But all these resistors was due to a catastrophic failure from the bias going out. And then it didn't only pop these transistors, it mutilated this combiner. Let me just take that off. This combiner and this combiner. Mutilated them. See it? How it bowled up? That is due to massive amount of heat. It got so hot it appears it even unsoldered this wire to this combiner, which is connecting these two tubes. And it appears that this side was unharmed. That's what it appears. I hope to God so. Hopefully we can get at least 4 working pills out of this thing, I hope. But I can pretty much say 10 out of 10, I'll say 9 out of 10 is to be safe that these pills are blown. I'm going to remove them all now and check them. So it looks like you have 4 that are good, and we'll see what type of health they're in as well. So this appears to be an overvoltage issue. Now here's the problem. If this resistor right here was to go out and become unusable or become shorted in some way, let's just say if this resistor was removed, okay, and these 10 ohms were removed, the DC electricity, 12 volts, 15 volts, whatever, then is only flowing through this white resistor, which is not going to give it enough resistance to drop that 12 volts or that current down low enough. And these transistors are going to be getting way too much bias current, way too much, to the point they are going to have a catastrophic failure. This is the only downfall about Texas Star's biasing circuit. You don't have that extra protection if something like this were to happen. There's different ways you can protect that. I mean, one of the most simple ways is internal fuses, you know, and all this type of stuff, you know. It would hopefully pop that fuse, you know. You look at it. Drop the phone. Dang, I did that yesterday too, and I haven't got my phone in a while. Dang. Anyway, you're basically looking at 100 milliamps per device just idling. And of course, they're going to pull more than that once you begin to key on them and stuff. But you would put a fuse there. If it would go above a certain point, it's going to pop the fuse, and then the transistors aren't going to have any bias at all. And at that point, it'll be running off Class C, basically flowing through this 1/8, 1.8 ohm resistor to ground. So just being Class C mode at that time. But the way they look at it, this doesn't happen that amount of times. It's not cost effective to put that extra protection in there, etc., etc. I have seen this happen a good bit. It appears, I can say it appears, I can't tell you 100%, but it appears that someone run this amplifier on a little bit too high voltage. And it threw off the bias circuit. And this resistor right here probably got too hot, had too much of a load on it. It popped it. When this one right here went, then you had more current going to the transistors than it needed to be. Way more. The voltage was way higher. I can't remember exactly what it would be, but then these transistors go into overload, working absolutely balls to walls, like a athlete on crank or something, you know, to the maximum, more than they even know how to. And then things heat up. Then this is why all four probably blown identically, because they all four had the same voltage, over voltage identically on the base of the transistors. And then of course when this happened and these transistors popped, now we have a full load going across these resistors right here, and these resistors cannot take that full load, so they are going to pop as well. But these resistors actually got so hot and stayed so hot. See, that's why a lot of times you can see one of these amps go out, you know, with popping a pill with RF or something, and this resistor will be blown, but the combiner, the ferrite, will still be good. I'm not using ferrite that's been this hot. I don't want to. I don't feel safe to. It's probably, you know, guarantee it's probably changed the permeability of the ferrite at this point. So these have to be changed out, of course, and etc. But they basically got so hot from these trying to take the full load of this mismatch from this whole section going out, and it, you know, throws everything off and smoke rolls out the box, etc. So anyway, you wanted me to show you a video of everything. I also saw this little small diode right here is blown, which I don't. Basically, all this, the reason why this diode is here is if you have the remote hooked up and you leave your remote on, but you turn the power off to your vehicle or whatever, and let's say you left this switch on with the remote plugged up or whatever, this right here, this diode is here to block the voltage coming this direction into the remote. So basically, if you have this turned on, it's not going to turn the LEDs on your remote. It's only wanting electricity to flow this direction from your remote. And so that's why a lot of people ask me, you know, will one of your Y motes work for a Texas Star? No, they won't. And the reason why they won't is because Texas Star's remote, the way they're built, they are not getting the power, the DC power from the box to power the remote. They're getting it from an external place, meaning the remote itself has a positive and negative wire to it. So you have to hook up a positive and negative wire to your remote from your car and then plug your remote in. You know, that's not really efficient to do. There's nothing wrong with doing it that way, don't get me wrong, But and I'll tell you the reason why they did it that way. The reason why they did it that way is to save money. Is to really save money, because they're using these connectors right here, okay? What they could have done is took these connectors off, okay? Put one 4-pin or 5-pin connector or whatever in here and pulled the power from here, so they could use one remote for the fans and to turn it on, the SSB delay on off and power on off, all of it do for one thing, one connector. But see, the thing is, I guarantee you they get both of these connectors right here cheaper or the same cost as one of those connectors, and this is a little easier, I guess, for them to hook up. But if they would have done that, which, you know, I still will offer a modification to do this, so you can run a Texas Star with the average remotes that are sold now from Fat Boy, X-Force, BBI, anybody else out there that makes remotes, the Amp Mode, the Y Mode, etc. I say that's a pretty good modification to do, honestly. But you'd have an extra hole right here to put another ground. Because the way they do this is they're breaking these up into 4 12-gauge wires. And if you think about it, this 2-pill section right here, although I know this has done turned into a dang teaching lesson. What the heck am I doing? This 2-pill section all the way down here is going to be getting less current than the one right here. It's got more wire. It's got a flow through to get down there, for one thing. Another thing, these things are being fed with 12-gauge wire. And I mean, this 2-pill section could pull up to 35 amps. You know, 30 amps. Yeah, so that's a decent little load on some 12-gauge wire now. I'm going to go ahead and tell you the truth. But what they go ahead and deal with the 8-gauge wire for the ground is bringing it in at one spot, pretty much on the middle 2-pill section, okay, and then flowing through with these jumpers. Now, at least they've got these jumpers 3-4 times the size of, let's say, the 4 or 500 667 cases. And of course, they had to use some high temp wire since it's down there like that. But if I ever do power wire upgrades, what I usually like to try to do is to use 2 8-gauge ground wires, and, you know, bring one in and drop it right there, and bring the other one in and drop it right there, and then go ahead and bring in 4 10-gauge wires or 4 8-gauge wires, whatever works out. And you've only got 4 things here to do. And what I normally like to do is put one each of the power wires right here, and then put 2 of the ground wires on this big one. But even coming in with 10-gauge wires, you're going to be better off than the 12-gauge. But or maybe even come in with some thinner 8-gauge than the one I use, which is from New Concepts. But that's the way you do a pretty good power wire upgrade. But yeah, man. So basically, stop from all my ranting. The box is in good condition. It really is in very decent condition. And it looks like we possibly may have just 4 transistors. So, you know, I'll work out the value of that and we'll figure it out. And then I'll just put this bad boy to the side, and on down the road, you know, maybe I'll fix it up and use it for myself, or fix it up and get it on down the road to somebody. You know, we'll just have to wait and see. But I'll work out the value, man. Looks good in your favor, though, the condition of the box. You can tell the box has been in some moisture area from the rust on it, but could have been near the beach. The top lid is not in real bad condition. It's not bent like crazy, like a lot of these I see come in, because these top lids, they hang out so much. They get bent up pretty bad during shipment sometimes. So the top lid don't look that bad. I just sand that thing down and repaint it, put some primer on that bad boy. Alright, man. There's your video. We'll see ya. We'll be back. We'll figure it all out, man. Oh, GK said it. I'm going. Bye-bye.